AP Chemistry, molar conversions. Let's consider some of the more straightforward molar conversions. These are one-step mole to mole and two-step gram to mole conversions. As always, we'll solve some problems mathematically, but then we'll do what the AP people want us to do and think about what the heck it means. So for each one of these, 1, 2, 3, I think there are 5 problems. We'll always be burning some butane. So imagine a Zippo lighter and you're just turning the thing on, if you will, creating a flame. 2 moles of butane will combine with 13 moles of oxygen to make 8 moles of carbon dioxide and 10 moles of water. Convince yourself that that's balanced and answer this question. How many moles of carbon dioxide will be produced from 1 mole of butane and excess oxygen? Well, since they're all equivalent, if 2 gives you 8, I guess 1 would give you 4. See that? 2 moles of butane gives you 8, therefore 1, half a scale, half a batch, will give you 4. However, if you have 17.26 moles of butane, how many moles of oxygen do you need? This is another one-step conversion. 2 requires 13, so we need 6.5 times as much. AP students, I'd recommend you simply do that in your head. 6.5 times 17.26. I mean, do the setup in your head. I think you would have to punch that in, but if you did, you would get 112 moles of oxygen. Another one-stepper, how many moles of butane react with 0.42 moles of oxygen? So if we have 0.42 moles of this, how much do we need? Well, it's 2/13. So I would probably, if I was in a hurry, do 2 divided by 13 and multiply it by 0.42. But to make sure it's right, I'd do a nice proper setup. Where do you start? With what you're given. Where are we going? To moles of butane. And every 13 moles of oxygen only requires 2 moles of butane. And so we only need 0.065 moles of oxygen. These are not particularly useful conversions to do, since you can't weigh anything out. You'd have to do a gram conversion. Here's a problem that does require grams, so we can say exactly how many grams you would produce. Start with what you're given. Recognize that mole to gram conversions are always 2 steps. There's what we're setting up, what we're given, knowing it's 2 steps, and it will make a certain number of grams of CO2. Maybe we can think about it too. 3 moles of this stuff. We got plenty of oxygen. I don't care. How many grams of CO2? Well, every 2 moles gives me 8, so it's a 4-fold increase. This will be 12 moles, each at 44 grams per mole. So I would simply multiply. This is 1.5, right? If 2 gives you 8, 3 gives you 12, right? 4-fold increase. 12 times 44 will be the answer. Here's the proper setup. Every 2 gives you 8. Every mole weighs 44 grams. Everything cancels nicely. And we have 528 grams of carbon dioxide produced. Try this one. If you want, try it on your own on a piece of paper by pausing and see if you get the right answer. The combustion of 4 moles of butane will require how many grams of O2? Let's think it out logic-wise. Well, 4 moles of butane, not 2. And I do need to know how many grams of oxygen. Well, mole-wise, it's 6.5 times as much. So that would be 4 times 6 is 24. I think 26 moles are required at 32 grams per mole. 26 by 32 should give me the answer, but set it up nicely. 4 moles of butane. Every 2 requires 13. That's a 6.5-fold increase. And each one weighs 32 grams. 2 times 16. 832 grams of oxygen are required for that reaction. For these 2-step processes, I recommend you also consider it by doing a reaction table method, which you can see in a subsequent slide.